This example is solving a rational inequality. The steps are the same as solving a polynomial inequality. The first step would be to move all the terms to one side. And in this case, all the terms are one side because I have a 0 on the right-hand side. So since the 0 is on the right-hand side, automatically all the terms are on the one side. The next step is to factor the numerator and denominator. Here again, I don't have to worry about the denominator because it's already factored. So the only thing I have to do is factor the numerator. So if I factor the numerator, I'm going to get x plus 4 times x minus 3 divided by x plus 1 less than 0. Okay, and the third step would be to find the intervals. So again, to find the intervals, the numerator, x plus 4 times x minus 3, this is called the x-intercepts. So this also has to be 0, so which means x equals negative 4 and x equals 3. And the denominator, x plus 1, is called the vertical asymptote or the restricted value and so on. So here x equals negative 1 is my restricted value or vertical asymptote. So using these numbers, I'm going to create the diagram, and from the diagram I will say what the intervals are. Okay, so the first thing is draw the number line. Again, in the number line, divide the number line into regions that you found here for this x values. So if I say x equals 0 is in the middle, right? Negative 1 will be to the left of 0, x equals negative 1. X equals negative 4 will be to the further left of negative 1. So x equals negative 4. And then to the right of negative 1 will be 3. You don't have to mark the 0 point. You just have to divide the number line into regions or into intervals. So the first interval is, so if I say the intervals, the first intervals is from negative infinity to negative 4. The second one will be from negative 4 to negative 1. The third one will be from negative 1 to 3, and the fourth one will be from 3 to infinity. Okay, these are the intervals. So like a couple of these intervals will be true and the others might be false. So anything that's true is where the solution is. So let me pick some test points to solve. So I'm going to pick a point here again, negative 5. So plugging back in, negative 5 plus 4 times negative 5 minus 3 over negative 5 plus 1. Again, I'm using the factored form just for simple calculations. I could have gone into the original too. So negative 5 plus 4 is negative 1. And negative 5 minus 3 is negative 8 divided by negative 5 minus 1 is negative 4. So this would be a positive 8 over negative 4, which would be a negative 2 less than 0, which is a true statement. Therefore, this piece will be in my answer. Okay, again, keep in mind here just it's less than. So that means that I cannot include any of these numbers. So these numbers are not included. Okay, now repeat the same thing for the next piece, where you can pick a test point. I would say x equals negative 2. So I'll have negative 2 plus 4, negative 2 minus 3 over negative 2 plus 1. Negative 2 plus 4 is 2. This would be a negative 5 over negative 1. So this would be a 10 over negative 10 over negative 1, which is 10. This cannot be less than 0, so that piece cannot be in the answer. Okay, now then third one, pick a test point here. I'm going to pick the point 0 because if this is negative 1 and that is 3, 0 will be here. So I'm going to go 0 plus 4 times 0 minus 3 over 0 plus 1. 0 plus 4 is 4. 4 times negative 3 is negative 12 over 1 is negative 12. less than 0, which is true, that tells me that this piece is my solution too. Again, repeat the same thing for the right-hand side of 3. My test point here is 4. Okay, my line disappeared. Hold on, let me draw it. Okay, 4. And if I plug it back into my given factored equation, so it's 4 plus 4 times 4 minus 3 over 4 plus 1, 8 times 1 over 4. 2 is less than 0, which is not true, therefore that cannot be in the answer too. So if you ask me what is the answer to this question, this is what you should write. The answer is all the intervals from -infinity to -4 and all the numbers from -1 to 3. So which here it's this interval, and this interval is where the solution is. Now another way of doing these problems, both polynomial inequality and rational inequality, would be to graph it. And the meaning of this inequality sign says, or whatever we did here says, the portion of the graph that's below the x-axis is your solution. So if I graph this inequality, then from -infinity to -4, I will see the graph below the x-axis, and from -1 to 3, I will see the graph below the x-axis. Between the interval of -4 and -1, and between the interval of 3 to infinity, the graph would be on the upper region. Okay, we can check that. So let me put this in. I'm going to write the original one. So it's x squared plus x minus 12, close parentheses, divided by, open a parentheses, x plus 1. Keeping the window the standard viewing window, and I'm going to hit graph. Okay, so it's very clear from this is my -1, -2, -3, -4. So from -4, it's below the x-axis, and I'm looking for below because of this problem has less than or equal, less than. If the problem was greater than, then I'll be looking it for above the x-axis. Okay, so we cross-checked it from -infinity to -4, it's below the x-axis, and also from -1 to 3 is also below the x-axis. Okay, and for the rest of it, it's above the x-axis. I hope you understood this. So that would be the answer.